Hi, so what I've got for you today is we're going to do some editing of the HISE source code, the C++ code, and I'm not a C++ developer, so I'm not going to be doing anything really fancy or anything, but basically Lyndon mentioned on the forum that there isn't a way to check if an effect is bypassed in HISE. There's no isBypassed function for effects as there is for some other modules. So I thought that sounds like the kind of thing that should be easy to add. So we'll have a look and see if we can do that. Now, like I say, I'm not a C++ developer, so I'm not really doing any C++. What I'm going to be doing is making a scripting wrapper function for the code that Christoph has already written. So basically, I'm just making Christoph's work accessible through the HISE scripting language so we can use it without having to write C++. So I will be editing the C++ files and I will be writing C++ code, but I'm not really adding any new C++ functionality. So let's just open HISE first. Don't need to make a new project. Let's just go over here and type isBypassed so we can see that the DSP module has an isBypassed function, the modulator does, and nodes, they have it as well. But if we wanted to check for effects, effects don't have an isBypassed function. So that's what we're going to try and add. And my method of doing this kind of thing is to find where it already exists. So I know it exists for modulators, and basically copy and paste it into the section for effects and then change it and test it until it works. So let's see how this goes. So this is the HISE source code. This is my install of the HISE source code. And the first thing I'm going to do, let's just have a look at Git. Okay, so I've changed a few things in there, but nothing important. So I'm going to make a new branch so I don't screw up my HISE install. So make a new branch and I will call this isBypassed, because that's the name of the function I'm going to try and create. So I'll just check that worked. So we're on the isBypassed branch. Okay, let's come out of the terminal. So the next thing to do is I'm going to open this folder in CUDA text. So I'm opening the HISE source code folder as a project in CUDA text, and this means I can search it for things and I've got access to all the code in this tree. Now, because I've dealt with some of this stuff before, I have a feeling that the stuff we need is going to be in this HISE scripting folder and inside this scripting folder. But if I didn't know that, what I'd do is I'd go to the top level folder and I would search through all of the files for a function called isBypassed. And let's just see what comes up. So it's doing the search. It takes a little while because it's going to go through all the files. Okay, so let's just collapse all these down. Oh, there's a lot of them. I wish there was a way to collapse all of them in CUDA text. Maybe I should request that on the forum. Wow, there are millions actually. I'm not going to be able to collapse all those, but let's just have a look through. Modules. Oh, well, this is probably getting close to what we want. That's modulators, effects. Let's keep going. Script node. Actually, I know it's in modulators, so I can narrow this search down a bit more. And the reason I know it's in modulators is because when we looked in HISE, we had it under modulators. So hopefully it will give me something for this search. Nope, nothing. Okay, well that was worth a try. Let's try this search. I'm just experimenting here. This is what I did the first few times I was trying to do this kind of thing. You just have to try different search terms until you narrow it down and you can sort of work out where the bit of code you want is. So let's just keep closing these down. So this is DSP stuff, and we do know that there is an isBypass function for the DSP modules. We saw that. But a lot of this that's coming up is where those functions are being used inside the HISE source code. What we want to find is the actual definition of that function. Okay, so we've narrowed it down. So HISE backend, it's probably not going to be in there. HISE scripting, it's probably going to be in here. What do we have? Scripting, script node, DSP, script processor modules is probably going to be under this one. Nope, not there. Modulators, what's in there? Nope, not there. Scripting API objects. Okay, this is probably where it is because I've seen a lot of stuff in here. There we go. So this is what a function definition looks like in C++. So whereas in JavaScript would do something like modulator dot is bypassed, in C++ instead of a dot you have 2 colons like that. So that's what you'll find in C++ when you're looking for a variable declaration. You'll have the sort of master object, so in this case scripting modulator, colon is bypassed. When the function is being called, you might see it being called with a dot, or you might see it being called with a dash and then a greater than symbol like we've got here. So it's just different ways to express the same thing. So this is the way C++ does it. Right, so this is what we want. So we're in the scripting API objects.cpp. There'll also be a .ah file to go with that. So here's the .ah file, and there it is. So this shouldn't be too tricky. So that's the .ah file I've opened up. So C++ is a strange language to me. I did study it a little bit at university about 10 years ago, but I don't really remember much. But C++ source code is made up of 2 parts. You've got a header file, which basically lists, it's kind of like a table of contents. So it lists all the names of the functions and maybe some variables and things. And then you've got the .cpp file, which actually implements the code. So you kind of have 2 places you've got to edit for one thing. And it's a bit strange to me, but that's the way they do it. So we're in here, so scripting MIDI processor, and how did I end up in here? But what I'm going to search for is bypassed. Is bypassed, there we go. So this is the function. Let's see if I scroll up. So yeah, scripting modulator, and then we've got is bypassed, checks if the modulator is bypassed. So we can see what the code is here. It's just, so it returns a boolean. It's going to return true or false. And that's the name of the function, and it doesn't require any parameters, and it's got const after it for some reason that we don't need to worry about. So I'm going to copy that. Now we're still in the header file, but I happen to know that we've got scripting modulator here. I happen to know that there's the effect, the code that handles effects is also in here. So if I type scripting effect, I think that should, yeah, here we go. So that's taken us to the section for effects, and we've got a similar sort of thing. And here where we've got set bypassed, I'm just going to paste that is bypassed under it. And instead of checking for a modulator, I'm just going to change this comment, checks if the effect is bypassed. And that should be everything we need for the header file. Now we've got to implement this. So we're going to go to the CPP file. And we're going to find the is bypassed function that already exists in here. So not there, not there. Where's the definition? Scripting modulator is bypassed. So I'm going to copy that. And now we're going to go to the scripting effect part in this function, in this file, wherever that is. Scripting object, scripting effect, here we go. And let's look, get attribute, set bypassed. So we'll put our function just here. So I'll paste that in. Okay, so now all we've got to do, this is obviously set up for scripting modulator, but we're going to change it so it'll work for the effect. So I'm basically just going to look at the function that's above it and see what I need to change to sort of make it work. So we can see that this function, which was already there, set bypassed, is just pretty much the same, except instead of saying scripting modulator, it should say scripting effect. And then this bit, we've got mod is bypassed. We don't want that. We're going to need effect. So I'll just copy that, paste that in there, and that is done. Now we've got the function there, this in C++. The last thing to do is to make it accessible from within HISE. So this is where we put a wrapper around it so that we can actually access it. And again, that's really easy to do. If we scroll up to the top of this section, we've got, here we go. So we're at the top of the section, scripting object, scripting effect wrapper. And we've got a nice comment up here to say it's the scripting effect section. So this wrapper stuff is where we get access to all our functions in HISE, and it's really easy to write one of these wrappers. So we can see it always starts with API method underscore wrapper. Some of them start with API void, but in our case it's API underscore method underscore wrapper. And then it's got an underscore, and it's either 0, 1, or 3 in this case, and that just refers to the number of parameters the function expects. And our function doesn't need any parameters because it's just returning true or false. So we're just going to copy one of these. Let's copy the one that's for set bypassed. We'll paste it under there. We'll change that 1 to a 0. And we'll, instead of set bypassed, we'll call this is bypassed. And then we've got to do the same thing down here. And again, change that to a 0 and change that to is bypassed. So I'm going to hit save on that. And now we'll build HISE and we'll see if it works, because I don't actually know if this is going to work. It's just an experiment for me. So we're in the source code. Now, depending on what operating system you're using, you'll have to build this in a different way. On Mac, you're going to use Xcode. On Windows, you'll use Visual Studio. I'm just going to use a makefile, and it's really simple. So I'm going into Projects, Standalone, Build, Linux Makefile, Build. HISE Standalone is my main build, so I don't want to overwrite that, so I'm just going to rename that to main. And then I'll open a terminal. No, I won't. I'm in the wrong folder. This one. I'm going to open a terminal. So on a GNU Linux operating system, there are many ways to compile source code, but the simplest way, when you have a makefile like this, we've got a makefile there, is to just open the terminal, and assuming you've got all the prerequisites installed, you just type make and hit enter. But I want to configure this. I'm going to build the debug version of HISE. And the reason I'm building the debug version is because I might need to debug the changes I've made if there's a mistake. And also it's just faster to compile because it doesn't take as long to build the debug version because it doesn't have all the optimizations of the release version. So because it's faster, it means I can test my results more quickly and find out if there's a problem. So actually, I'm just going to make a backup copy of my main install there. I'm just going to put it on the desktop for now. Because what I'm going to do, I'm going to delete this existing build folder, because sometimes those intermediate files can screw up a new build if you've made changes. So I'm just going to delete that to make sure that doesn't happen. And now I'm going to type make config equals debug. And I'm going to put -J8. And that -J8 just means I want it to use 8 of my processor cores. So it'll just compile a bit more quickly, that's all. I'm going to hit enter, and this will take a moment to run through the build process and the linking process, but I'll speed up the video so you won't have to sit through that. Okay, so that build's completed. It didn't take too long. And if we go into the build folder, there it is, HISE Standalone. I'm going to open it in the terminal just so I can debug if necessary. Let's have a look. Let's cancel that. Failure in the preset handler. I didn't change anything in there, so I'm going to assume that's not a problem caused by me. Right, let's see if this works. Now, usually we'd go over here and look for our functions, so we'd type in is bypassed, but I haven't figured out how to make the changes that I make to the HISE source code show up over here, so we'll have to wait for Christoph to do that once I've pushed this change to GitHub and he's incorporated it. He can make it appear in the API browser. So we're just going to test to see if it actually exists and if it works. So I'll add an effect. Filter. We'll add interface script. We'll get a reference to the filter, paste that in. And then we'll just run the script, run the function and see if it works. Console.print filter1.isBypassed. And we'll see what comes up in the console when I click compile. Hopefully it'll say 0. Right, it says API call with undefined parameter. So that means it can't find the function, so something has not gone according to plan. Let's see if anything comes up in here. Nope, so filter1.isBypassed. Not finding that as a function. Okay, so this is the trial and error process I go through when I'm making these tweaks in C++, and this is because I'm not a C++ coder. So now I close this, I go back to C++, and see if I can work out where I made a mistake. So we've got the API method 0, that's definitely there. And this one is bypassed. Okay, so that's, yeah, scripting effect. Oh, hang on. That might be why. When I copied and pasted set bypassed, I didn't realize that that's an API void method. But of course, Void means it doesn't return anything, whereas ours does return true or false. So I think I need to delete that void. And I think that should be fine down here. Yeah. Okay, so I'm just going to make that tiny change and let's rebuild and see if it works. The build process is clever. It won't take us long to build this time because it's already compiled most of the source code. It's only got to take care of these, the files that have changed. So that's finished building already. It's just doing the linking now, and because I'm doing the debug build, that will only take a moment. If this was the release build, then the linking process can take a few minutes. There we go, that's done. Let's run it. And hopefully it'll work this time. If not, I just go back to the trial and error. So we'll do the exact same thing, print filter1.is bypassed. Yay, it worked. So it shows a value of 0, which is correct because we haven't bypassed it, so it should be 0. So now I'm going to bypass it, and when I refresh, that should change to a 1. Yay, it changes to a 1. So great, we can now check if an effect is bypassed or not bypassed. I'm probably going to go through this actually and see what else we can do that with, because basically anywhere where we've got set bypassed, let's have a look. So we've got set bypassed for all of these different modules. So the audio sample processor has set bypass, Charles Synth has it, DSP effect, MIDI processor, modulator, node, and slot effects. They all have a set bypass function, but only a few of them have the is bypass function. So what I'm going to do after I've finished this video is I'm actually going to go through, and for all these where it says set bypassed, I'm going to make sure there is an is bypassed function as well, because it makes sense to have that, and I like going through and adding these little extra functions that are just sort of a little bit helpful. Somebody will find them useful, so it's nice to have. Okay, so that works, that's great. I could build the release version of HISE now. I won't do that yet because like I say, I'm going to add more functions. But what we need to do is get this going up to GitHub so everybody else can access it. So let's go to my HISE source code folder. We'll open up a new terminal, minimize that one. Git status. So it's saying I've edited these two files, which was the CPP and the .h. These ones, well, these juicer files I edited a few days ago. It's unrelated to the work we've just done. So I'm going to just push the changes I've made to these two files. So I'm going to do git add hi underscore scripting, and those two files have now been put in the staging area. That's why they've gone green. And I'm going to do git commit added effect is bypassed function. Should we call it function? We'll call it wrapper. There we go. And now what I want to do is merge this branch, because you remember we made a new branch for this. I want to merge this into my main development branch, which I'll then push to GitHub. So I'm going to switch to my develop branch. Oh, and yeah, notice that this updated in the background because I've switched to the develop branch, which doesn't have those changes. I'm just going to close CUDA text for now. Okay, so we're on the develop branch. Let's make that a bit bigger. Let's clear that. And we'll go git branch. So we're going to merge the is bypassed branch. So we just go git merge is bypassed. Just check everything's okay there. Yeah, git log. So there's the change we made. Added effect is bypassed. So that's just been made. And now I'm going to push this to GitHub. So now it's available on GitHub in my repo. If you go to github.com/ I think it's /David Healey or /D Healey, I forget which one. And I have a HISE repo there, which is a fork of Christoph's repo. And in there you'll find the develop branch with this change made and some other changes. These changes are already being pushed over to Christoph's GitHub as well. I've made it what's called a pull request so he can access these changes, and hopefully at some point in the future when he releases the next version of HISE, he'll merge all my changes in as well, so all of these should become official. Right, I hope this little bit of experimentation has opened up some interest for you in editing the HISE source code. It's not difficult to do, to go in and make little tweaks like that, and even more significant changes don't take that long really. I mean, I added I linked presets to expansions sometime last year, and that took me about a week to do because I have no idea with C++, so it was a lot of experimentation. But little changes like this, it doesn't take too long, and you can make some quite significant differences when it comes to your HISE scripting through adding these extra little wrapper functions. So do check out the HISE source code. Don't be afraid to play around with it, and if you make a new branch in Git before you start playing, then you're not going to ruin anything because you can always just go back to the previous version. Thank you for watching. I hope you found this useful. If you've got any questions, hopefully not C++ related, feel free to ask them, and I'll see you next time.